Welcome back to Low Stress Math with Mrs. Bono. We are on Book 2, Chapter 3, Lesson 7, Linear Functions and Applications. So, this is where math in the real world starts. A lot of times, graphs are used. You see them in newspapers and on websites, and even sometimes in other places. But you have to be able to read and interpret a graph, which is kind of what we're going to be doing. So let's start at the beginning. A swimming pool, when full, holds a certain amount of water. When the drain is open, the amount of water in the pool drains out at a constant rate. Constant rate, when you see those words, constant rate is going to be your slope. And if you're looking at this picture, you can see this is a negative slope. It's going down. The graph shows the amount of water, Y, so here's the water, in the pool X hours after the pool is opened. Now, always time is going to be the X. Time is very consistent. So, time and gallons. What is the vertical intercept, the Y-intercept of the graph? There's always more than one way to say something. So we're looking for the y-intercept or the vertical intercept. Remember, vertical, just like we were talking about, vertical intercept. I want to point something out, make it really big for a second. Look at this little zigzag, because this says 0, and this says 244,000, and this is 48,000. This is 348,000. It's 404. It's going up by 100,000. And yet, this is not 100,000. That little zigzag says that they skipped a bunch of numbers. It's important to know when that happens. Look for those little jumps. So we were down here, and what information does it tell you about the situation? Well, here's the y-intercept, or the vertical intercept. And what is it? It is 648,000. And the important part about that is writing the unit. Amount of water, gallons, G-A-L. What does it tell us about the situation? Well, initial or starting amount. That's what it tells you. It tells you how much water was in the pool when it started. Initial, it's the initial amount of water, or the beginning amount of water. So, 648,000 gallons were in the pool before the drain was opened. Okay, find the slope. What information does that tell us? Well, slope, of course, is rise over run. And when they're asking you what information it tells you, or what does it mean, or anything like, explain it, the best thing to do to help you explain something is to put the units on. So I'm going to do from point to point. So here it is at 248,000, and it goes down. So from here to here, it goes down negative 100, 200, 300, 400,000. And then it starts at 0 minutes, and it goes all the way to 200 hours. Wow, that's a very long time. So it goes 200 hours. So 400 gallons, 200 hours. This is the rise. This is the run. So rise over run. Well, let's figure it out. Slope M equals rise over run. And in this case, it's negative 400,000 gallons of water, because that's going to be important in a minute, over 200 hours. So I have to put that into my calculator. I mean, of course, I could divide, but you've met me, I'm a bit lazy. So negative 400,000 over 200 hours is negative 2,000. Negative 2,000. What does that mean? Well, I have to put the units. Gallons over hours, or gallons per hour, because this is really over 1 per 1. So negative 2,000 gallons per hour. So that means the water is draining out of the pool at 2,000 gallons per hour. That is a very big drain, I might say. All right, so what information does it tell you? The water drains from the pool (2,000 gallons per hour. That little slash also means per. Just used to it. Write a linear function that can model the situation. Well, this up here, 648,000 gallons, that's the b. It's the y-intercept. And down here, the negative 2,000 is the m, or the slope. So y equals mx plus b, y equals negative 2,000 times x, the number of hours, plus 648,000. How much water is draining out of the pool? How much water was in the pool to start with? You can find out how much water is in the pool at any time by filling the number of hours the drain has been opened. And then it'll tell you how much water is left in the pool. Okay, let's try the next one. Here we go. When you're doing word problems, it's vital that you understand what you read. And sometimes the words are really important, and sometimes, like names of people, you could just skip. But Joe pays a fixed amount. Fixed amount, what is that? That is the starting amount, or is that the slope? A fixed amount each month. To use his cell phone. He also pays for each minute that he talks on the phone. Each minute he talks on the phone. The graph shows the amount C dollars he pays in a given month. Well, how do I know which one is which? Which one's the y-intercept and which one's the slope? Well, here you go. It's starting at $10, and then the air time is in minutes. That means each minute he talks, that's going to be the slope, because it's got minutes and it's got dollars. It's going to have both. This one is just a fixed, it's only once. Okay. So what's the vertical what is the vertical intercept? We're just going to write y-intercept over that of the graph. What information does it tell us about the situation? Well, here's the y. Here's the y-intercept. And what does that tell us? It tells you that his bill started with $10. So B equals $10. And what does that mean? Before he even spoke a word on the phone, he paid $10. So his bill, should make that a capital, starts at $10. Find the slope. Well, that's easy enough. We're going to do rise over run, and this is a positive slope. So let's see. From 10, 20, 30, it's going up $20, and over 50, 100, 150, 200 minutes. So my rise is $20. My run is 200 minutes. Okay, so rise over run, 20 over 200. $20 over 200 minutes. What does that mean? It's $1 for, why did I write minutes over there and not next to where it belongs? Minutes. Right. Over 10 minutes. So it's $1 for every 10 minutes. What does it tell us about the situation? Or $1 for 10 minutes. Or 10 minutes for $1, however you want to think of it. Right. Write a linear function that represents a situation. Well, the b is $10, the m is $1 for 10 minutes, it's 1/10. So y equals 1/10 x plus $10. If Joe talks for well, Joe is a chatterbox, isn't he? Let's try this. Y equals 1/10, and it's 350 minutes. Minutes is x. So 350 plus $10. So grab my handy dandy calculator. Y equals, now this is going to be dollars because, let's see, 1/10 times 350 plus $10 is $45. That makes sense. $45 for a phone, $45 for his phone bill. And that's going to change every month. Let's try this page. Okay, Jeanette rents a bike while visiting a city. She pays $7 per hour to rent the bike. Ooh, remember we talked about that word per? That's usually where the X goes. So that means that $7, that's my slope. She also pays $8 to rent a baby seat for the bike. Well, when you're renting a baby seat, do you rent it by the hour or you just rent it one time? I think you just rent it one time. She paid $8 to rent the baby seat for the bike. She pays this amount for the baby seat no matter how many hours she rents the bike. Good. The graph shows her total cost, Y dollars and X hours. So here's the y-intercept. $8. That $8 is the baby seat. Baby seat. It tells us up here, $8 to rent a baby seat, and the y-intercept is $8. That's the baby seat. And it's going up, let's see, 8, 16, 24. It goes up by 8. So it's rising $56 over the run is 8 hours. Wow, she was on that bike a long time, huh? Okay. So, what is the vertical intercept and what information does it give us? $8 to rent the baby seat. Now, find the slope of the graph. Okay. M equals rise is $56 over 8 hours. And let's see, what does, grab your calculator. If your division is not good, don't do it. 56 divided by 8 is, yay, $7 an hour. $7 per hour. And look, I even knew that already. It's up here, slope, $7 per hour. $7 per hour to rent the bike. I was gonna write 2-2. Look at that, silly Bono. All right, now we have to write an equation or a linear function. Linear function and equation mean the same thing at this point. Don't worry about it. Y equals $7 per hour plus $8 for the baby seat. Now, oh my goodness, she's gonna rent it for 14 hours? Where is she biking to? Well, wherever it is, it's a long, far place away. So Y equals 7 times 14 plus 8. All right, so 7 times 14 plus 8. No need to math when you have a calculator. $106. So she would pay $106. She will pay $106 for 14 hours. All right. Not hard. We're getting there. We've got, what, 2 more problems, I think. Yeah? Yes, 2 more problems. Here we go. Example 4. Bill lights a candle and records its height at various. Bono, bono, bono. These are his results. Based on the table, how tall was the candle before it started to burn? And what does that represent? Well, we've talked about tables before. Remember, where the x is 0, the y is the y-intercept. So, 0 hours means they have not started to burn the candle. So it was 9 inches tall. So, at 0 hours, the candle was 9 inches tall. What is the slope of the candle being burned? Well, depending on how you want to do it, delta x, delta y, 9 to 7, -2, 7 to 5, -2, 5 to 3, -2, plus 1, plus 1, plus 1. So, change in y over the change in x is the m, the slope. Change in y is -2, change in x is 1. Put the units on, inches and hours. So what does that mean? The candle burns 2 inches per hour. There you go. How can we write an equation to represent the number of hours the candle burned, x, and the height of the candle, y? Y equals, m is -2 over 1, -2, I don't have to write over 1, x, plus it was 9 inches tall to start. Okay. Ashley plants a flower in her backyard. Nice for Ashley. And let's do delta x, because weeks planted, time is always x, everything else is usually y. So delta x and delta y goes up by 3. And this is going up by 6. Yes, 6. And there is no 0. Oh no! I'm going to go backwards and get a 0. I'm going to subtract 3 to get 0, and I'm going to subtract 6 to get 9. That way I have my y-intercept. I'm going to do it the other way because I have lots of space over here, but just keep in mind that what is the rate of change of the height? Here we go. M equals change in y, delta y over delta x. Delta y over delta x is 6 over 3, which is 2. What does that mean? Well, the 6, the delta y, is inches, and 3 is weeks. So what does that mean? It grows 2 inches per week. What information does the slope tell us? The plant grows 2 inches per week. What is the y-intercept and what does that tell us? Now, I already found the y-intercept by working backwards. So I know b equals 9 inches, because it's here with the plant. And what does that mean? The plant was 9 inches when it was planted. The plant was 9 inches when it was planted. Write an equation in slope-intercept form representing the number of weeks after Ashley plants the flower and the height of the flower in inches. So y equals, the slope is m, 2x, plus the 9 inches it was when it started. All right. Here we go. Oh, goody, goody, goody. It gave me a 0. Now, it also gave me different variables, m and t, but I'm not going to be fooled by that. I'm going to pretend that this is x and this is y. So the change in t and the change in m. Now this is going up by 1s, and this is going up by 5s. So what is the rate of change, the slope, and what does it tell us? The change in y, change in t, over the change in x, which is the change in m, equals 5 temperature, t. Temperature in what? Doesn't tell me. Time, it tells me. Oh dear, it doesn't tell me what the temperature, he records the results, but it doesn't tell me what the temperature is. You know what? I am going to pretend it's Celsius. So, the change in temperature is 5 degrees Celsius, and the change in time is 1 minute. What does that tell us about the situation? What it tells us is the temperature rises 5 degrees Celsius every minute. Yeah. Sorry. What is the y-intercept? What does it tell us? It said the y-intercept at 0 minutes is 25 degrees. That tells us the temperature was 25 degrees before Mr. Horsley heated the liquid. So, B equals 25 degrees Celsius, which is the temperature. Of of the liquid before which is the temperature of the liquid before it was heated. So the slope, m, is 5/1. The y-intercept is 25. The equation is going to be, and normally I would write y equals mx plus b, but the y here is t equals 25. And instead of x, I have to write m plus 25. Why did I write 25? Oh dear, I've made an error. It's not 25. The temperature rises 5 degrees, not 25 degrees. Silly Bono. Thank goodness for whiteout. Now, what if I had written everything as y and x? Can I tell you, if you put y and x up here and you wrote everything else in y and x, I would not take any points off for you, as long as you clarify what you're using for x and what you're using for y. You don't lose points. But if they're telling you to use temperature and minutes, then you should use temperature and minutes. Okay. Independent practice, everyone's favorite part. There's your homework, page 84. Oh, and 85. And, yeah, that's enough. All right, take care. I will talk to you soon.